China is building things that have never existed before. Today, we're counting down the 10 most insane Chinese megaprojects happening right now in 2026. Number 10. The airport rising from the sea. Dalian, Jinzhouwan. Imagine you need a new airport, but your city is surrounded by mountains and ocean, and there's simply no land left to build on. What do? If you're China, you build the land first. Off the coast of the northeastern port city of Dalian, engineers are doing something that sounds like science fiction. They're constructing a brand new island in Jinzhouwan Bay, 20 square kilometers in size, and when they're done, they're going to build one of the largest airports in the world on top of it. To put that into perspective, 20 square kilometers is bigger than Manhattan south of 42nd Street. The island is not just sand dumped into the ocean, but sitting on more than 3,000 concrete and steel piles drilled directly into the bedrock below the seafloor, some of them plunging 80 meters deep. That's 3 times deeper than a typical land airport foundation. Building this on dry ground would already be a massive challenge. Building it while standing in the ocean is a different beast entirely. By mid-2025, 94% of the island's footprint had already been formed. In September 2025, a major construction company won the contract for the terminal building and the elevated bridge connecting the airport to the mainland. When it's complete, Dalian Jinzhouwan will have 4 runways, a terminal covering 900,000 square meters, and enough capacity to handle 80 million passengers a year. The airport surpasses Japan's famous Kansai Airport, which was also built on an artificial island in every single dimension. Now, this is a long game. The first phase isn't expected to open until the early 2030s, with full completion likely around 2035. Construction delays from flooding, financing, and the pandemic pushed back what was once an optimistic 2026 opening. But the island is real, the piles are in the ground, and the contracts are signed. Number 9. The desert that became a grassland. China's solar mega farm. Here's something wild. China built one of the world's largest solar farms in the middle of a high-altitude desert, and 3 years later, so much grass started growing underneath the panels that they had to import 20,000 sheep to eat it. That's not a joke. The Talatan solar complex, sitting on the Tibetan plateau in Qinghai province, is one of the most extraordinary renewable energy installations on Earth. By 2026, it was generating around 21 gigawatts of power and producing over 18,000 gigawatt-hours of electricity every single year. How much is that? Enough to power tens of millions of Chinese homes. The solar panels, it turns out, create shade. The shade traps moisture. The moisture grows grass in land that was 98% bare sand. The grass holds the soil, and the soil stops the desert from spreading. China planted a power plant and accidentally grew a field. But that's only one of China's solar mega projects right now. In the Gobi Desert, engineers just switched on a dual-tower solar thermal plant, the world's first of its kind. With 27,000 mirrors concentrating sunlight onto 2 towers that are 200 meters tall, standing 1 kilometer apart, the plant generates heat day and night. And in Xinjiang, the Midong solar farm, currently the world's largest single solar installation at 3.5 gigawatts, went live in 2024, powered by 20,000 construction workers and over $2 billion of investment. China's goal: 455 gigawatts of solar built in desert regions alone by 2030. That's more than the entire current generating capacity of some continents. Number 8. The train that almost flies. The CR450 high-speed rail. In most countries, a high-speed train does around 300 kilometers per hour. That's already fast, about as fast as the cruising speed of a small propeller plane. China's new CR450 train does 400 kilometers per hour. At that speed, you could go from Paris to Rome in under 2 hours. You could cross the width of France in about 45 minutes. The CR450, unveiled in Beijing in late 2024, is right now completing its final design testing in 2026 before it enters commercial service. During test runs, the train hit 453 kilometers per hour. At that speed, when 2 trains pass each other going opposite directions, the combined relative speed is nearly 900 kilometers per hour. That's close to the speed of sound. Here's the engineering trick that makes this really remarkable. Despite being 10% lighter than its predecessor and moving 50 kilometers per hour faster, the CR450 stops in the same distance as the older, slower train. Engineers redesigned the braking system so completely that faster doesn't mean longer to stop. It's the equivalent of building a sports car that accelerates harder but brakes in a shorter distance than the family sedan it replaced. The train carries 4,000 sensors that monitor every critical system in real time. It's 22% more aerodynamic. It uses 20% less energy per passenger. And China already has nearly 50,000 kilometers of high-speed rail, about 70% of all the high-speed rail on Earth. The CR450 isn't just a new train. It's an upgrade to a network that's already the most advanced transportation system any single country has ever built. Number 7. A lab buried beneath a mountain. The Jinping Underground Laboratory. Picture the deepest, most remote spot imaginable. Now go 2,400 meters below it. That's where China built the world's largest and deepest underground laboratory, the China Jinping Underground Laboratory, hidden beneath the Jinping Mountains in Sichuan province. It's so far below ground that if you dropped something off the top of the rock above you, it would take a very long time to reach where you're standing. Why would you build a lab underground? Because of a thing called cosmic ray noise. Every second, invisible particles from space cosmic rays are raining down through everything around you right now. You can't see them, you can't feel them, but if you're trying to detect something as rare and elusive as dark matter, those background particles drown out your signal completely. The only way to block them? Rock. Lots and lots of rock, over 2 kilometers of it above your head. China's Jinping Lab recently expanded to become the world's deepest and most shielded underground research facility. Scientists from around the world come here specifically because there's nowhere else on Earth that's this quiet. This is where humanity is most likely to finally prove or disprove whether dark matter actually exists. It's also part of a wave of big science facilities China is now building alongside its traditional infrastructure. Massive underground detectors, artificial suns, and tools to study the universe. China overtook the United States in scientific research output in 2022 and has been accelerating ever since. Quick pause here. If you're finding this kind of deep dive valuable, it genuinely helps to know. These documentaries take a lot of hours to research and put together. If you want to support the channel and help keep this kind of content coming, there's a link in the description and in the pinned comment where you can make a small donation, whatever feels right. No pressure at all. Now, back to the story. Number 6. The JUNO Neutrino Observatory. About 700 meters underground, near the city of Jiangmen in southern China, there's a sphere. It is 35 meters across, roughly the height of a 1-2-story building, and it is filled with 20,000 tons of a special transparent liquid. Its job is to detect neutrinos, tiny, almost massless particles that were created at the birth of the universe and have been flying through space and through you ever since. Right now, billions of neutrinos are passing through your entire body every second. You will never feel a single one. This is the Jiangmen Underground Neutrino Observatory JUNO, and it turned on its detector in 2025 after a decade of construction and serious flooding delays that pushed back the timeline by years. In November 2025, JUNO released its very first results, and they were already the most precise measurements of neutrino behavior ever made, more precise than any similar experiment in the past decade. Over the next few years, JUNO is expected to answer one of the biggest open questions in physics. What is the correct mass ordering of neutrinos? This sounds deeply technical, but the answer could explain why matter exists at all, why the universe after the Big Bang didn't just annihilate itself in a perfect matter-antimatter explosion and leave nothing behind. We exist because of an imbalance. JUNO is trying to figure out exactly how that imbalance happened. Not a bad use of a giant sphere filled with liquid underground. Number 5. The train that doesn't touch the ground. China's 600 km/h Maglev program. Now the CR450 we just talked about. Incredible engineering, but it still has wheels. It still touches the track. It still plays by the same rules trains have played by for 200 years. This next project throws all of those rules out completely. Here's a question. What happens after you build the fastest conventional train in the world? You build one that doesn't touch the ground at all. China's CRRC, the world's largest train manufacturer, has been developing a maglev train designed to travel at 600 km/h. To understand what that feels like, a regular car on a motorway does about 130 km/h. China's current fastest high-speed trains do 350 km/h. This maglev does 600. That's faster than a cruising propeller aircraft. That's close to the speed of a fighter jet on a low-altitude pass. The train works by floating. Powerful electromagnets underneath the carriage repel the guideway below it, lifting the entire train a few centimeters off the surface. No wheels, no friction, no contact with anything. Just a 600-ton vehicle gliding silently through the air at speeds that would have seemed like science fiction 20 years ago. The full-scale prototype was unveiled in Qingdao in 2021 and showcased again at China's Modern Railways exhibition in Beijing in July 2025. Right now, dedicated test tracks are being built and expanded, including at the CRRC Changchun facility, specifically to push the technology toward the speeds needed for commercial operation. And then there's the number that stops people cold. In late 2025, researchers at Donghu Laboratory in Hubei province ran an uncrewed test vehicle on a 1-kilometer maglev track and hit 800 kilometers per hour in about 7 seconds. That is the fastest any ground vehicle has ever moved on a test track. Ever. Anywhere on Earth. Now, to be clear, that was a small uncrewed sled, not a passenger train. The full passenger system is still years from commercial service, but the physics is proven, the records are real, and the test infrastructure is being built right now. When a commercial 600 kilometers per hour maglev line eventually opens in China, the trip from Beijing to Shanghai 1,300 kilometers would take about 2.5 hours, faster, door to door, than flying. Number 4, the railway that goes where no train has gone before, the Xinjiang-Tibet line. There's a stretch of terrain in western China that engineers avoid talking about in detail, because the details make the challenge sound almost impossible. The Xinjiang-Tibet Railway will run approximately 2,000 kilometers, connecting Hotan in Xinjiang to Lhasa in Tibet. To do that, it must cross the Kunlun Mountains and the Ganges Mountains, some of the most extreme terrain on the planet, altitudes where workers need oxygen just to function, permafrost so unstable that conventional foundations sink, temperatures that swing more than 60 degrees Celsius between seasons. In August 2025, China formally registered a dedicated railway company with 95 billion yuan in capital, about $13 billion, and announced that preliminary surveys were complete and construction was beginning. This is a project China's infrastructure planners had been preparing for years, and now it's happening. Why build it? The railway will open up one of the most remote and hard-to-reach corners of the planet, connecting China's northwest to its southwest, unlocking new trade routes, and bringing modern transportation to communities that have never had it. It's about economic development reaching places where the terrain once made it seem impossible. The engineering challenge is extraordinary, and they're doing it anyway. Number 3, the artificial sun that could power civilization, China's fusion program. Since the 1950s, scientists have dreamed of building a sun in a box, a machine that fuses hydrogen atoms together and releases almost unlimited energy, with no carbon emissions and no dangerous waste that lasts for thousands of years. The joke has always been, fusion is 30 years away, and it always will be. China just made the joke a lot less funny. On the 20th of January 2025, China's East Tokamak, the experimental advanced superconducting tokamak, operating in Hefei, shattered the world record for sustained plasma confinement. Scientists kept superheated plasma, running at over 100 million degrees Celsius, for 1,066 seconds. That's just under 18 minutes. Why does that matter? Because the core of our actual sun runs at about 15 million degrees. East runs 7 times hotter than that, and it held it stable for nearly 18 minutes straight, more than doubling the previous record it had set just 2 years earlier. Here's the catch that makes this even more mind-bending. Maintaining that plasma, without it touching the walls of the reactor, because nothing on Earth can physically withstand 100 million degrees, requires a perfectly sculpted magnetic field that holds the plasma like an invisible cage. For 1,066 seconds, that cage held. China is now the world leader in plasma confinement time. It is a core partner in ITER, the international fusion reactor being built in France, and it has already published detailed designs for its own next-generation machine, CFETR, intended to be the first fusion reactor that actually produces more power than it consumes. CFETR is not yet under construction, but the record East just set is the scientific proof of concept that makes it possible. The country that gets fusion working first doesn't just solve its own energy problem, it holds the key to the energy future of the entire planet. Number 2, the railway at the top of the world, the Sichuan-Tibet line. If you drew a straight line on a map from Chengdu to Lhasa, it would look simple 2 major Chinese cities, about 1,700 kilometers apart. Currently, the trip takes over 34 hours by train on the long way around. The Sichuan-Tibet Railway will cut that to 13 hours. To do it, engineers are building what might be the most technically difficult railway ever attempted. The line crosses 21 mountains over 4,000 meters high, traverses 14 major rivers, and passes through some of the most geologically active ground on the planet, where the Indian and Eurasian tectonic plates are still actively crashing into each other. Earthquakes are common, landslides are common, tunnel collapses are a serious risk. The solution? About 95% of the entire line runs through either tunnels or bridges. Only 5% of the track is built at ground level in the conventional sense. It's not so much a railway as it is a 1,700-kilometer tunnel and bridge structure that happens to carry trains. Completion is targeted around 2030. When it opens, one of the most isolated regions in the world becomes a 4-hour train ride from one of China's most dynamic economic hubs. Number 1. The dam that will change everything, the Motuo hydropower station. On the 19th of July 2025, Chinese Premier Li Qiang stood at a ceremony in Ningxi, Tibet, and called it the project of the century. He wasn't exaggerating. The Motuo hydropower station, now under construction on the Yarlung-Tsangpo River in Tibet, will be the single largest power-generating structure in human history. When complete, it will produce 300 billion kilowatt-hours of electricity every single year. To understand what that means, the Three Gorges Dam, currently the world's most powerful dam, generates about 111 billion kilowatt-hours per year. Motuo will produce nearly 3 times that amount, all from one project. The Yarlung-Tsangpo River drops 2,000 meters in elevation in just 50 kilometers as it winds through a canyon on the eastern edge of the Tibetan plateau. That's an energy engineer's dream, a river falling like a waterfall, over and over for 50 kilometers. 5 cascade hydropower stations will harness that fall, feeding electricity through ultra-high voltage lines to Sichuan, Yunnan, and beyond. The price is approximately around 1.2 trillion yuan, roughly $167 billion. That's more than the GDP of many entire countries. Construction is underway now, with a target to be operational by the early 2030s. The scale of the project also raises important conversations about river ecosystems downstream. The Yarlung-Tsangpo flows beyond China's borders and becomes the Brahmaputra River, supplying fresh water to tens of millions of people across South Asia. Engineers and environmental scientists are studying how to manage the river's flow responsibly, because a project this large has a responsibility that stretches far beyond the dam walls themselves. The dam will generate enough clean power to lift hundreds of millions of people away from fossil fuels. And the engineering lessons learned building it will influence how the world approaches large-scale clean energy for decades to come. That's the weight of building the most powerful dam in human history. If you made it this far, thank you. Genuinely. Videos like this take dozens of hours to research, write, and produce. If you enjoy this kind of content and want to help the channel keep making it, you can make a small donation through the first link in the description or the pinned comment. There's no subscription, no obligation, just a direct way to say you want more of this. Every contribution makes a real difference. China is spending trillions of dollars building things that have never been built before. Airports from ocean, railways through mountains, dams that dwarf anything humanity has ever constructed. Most of these projects don't fully open until the 2030s. The ones being built today are just the foundation for what comes next. What will the world look like when all of this is finished? And what is China planning to build after that? We'll get into that in the next videos.